all of you to the one-day international web conference on advances in explainable and resilient AI for security and language intelligence, jointly organized by the Department of Computer Science and Department of Artificial Intelligence and Machine Learning on 24 July 2026. Today marks a significant occasion as we come together to exchange knowledge, explore innovative research, and discuss the latest advancement in artificial intelligence, cybersecurity, and language intelligence. Your gracious presence has added immense value and prestige to this international gathering. We are deeply honored by the presence of our distinguished dignitaries whose unwavering support and visionary leadership continue to inspire academic excellence and innovation. A special and cordial welcome to our renowned resource person, Dr. Palnichami Naveen and Dr. R. Usharani. Their remarkable contribution to artificial intelligence, digital innovation, and emerging technologies have inspired many researchers and educators. We eagerly look forward to their insightful section, which will undoubtedly broaden our perspectives and deepen our understanding of this rapidly evolving field. The theme of today's conference highlights the growing importance of developing AI systems that are not only intelligent but also transparent, explainable, secure, resilient, and ethically responsible. As AI continues to transform industries and society, such discussions become increasingly important in shaping a trustworthy digital future. I take this opportunity to express my sincere gratitude to our management, organizing committee, faculty members, student coordinators, and volunteers for their tireless efforts in making this international conference a reality. To all the participants joining us from various institutions and organizations, thank you for being part of this academic journey. I hope today's section will inspire new ideas, foster meaningful collaboration, and contribute to your professional and research aspiration. Once again, I extend my warmest welcome to each one of you. May this conference be enriching, inspiring, and a memorable learning experience for all. Thank you, and I wish you all a successful and enlightening conference.
Now I invite our strategic head sir to facilitate the gathering.
Good morning, everyone. Can you guys hear me? Good morning. Can you hear me? Can you guys hear me? Okay. So, good morning, everyone. Again, it gives me immense pleasure to welcome you all today's international seminar. I extend my warm welcome to our esteemed resource persons, Dr. Palnichami Naveen and Dr. R. Usharani. We are truly honored to have you both with us today, and I hopefully believe that this conference will be a success and very useful for our participants. I also would like to welcome our student members, staff members, and all the participants who have joined us from across the world. And I would like to congratulate to the Department of Computer Science, Artificial Intelligence, and Machine Learning for their success on conducting this program. Very congratulations for everyone, and all the participants here. This will definitely be a useful time for you, and I hope everyone can learn something new today. So pay attention, and thank you so much. Have a great conference.
Now I invite Ms. L. Sneha to introduce our first resource person.
Respected Secretary, respected principals, honorable dignitaries, distinguished guests, esteemed scholars, and this book to introduce our distinguished speaker for today's international conference. We are honored to welcome Dr. Palnichami Naveen, Assistant Professor in the Faculty of Computing and Mathematics, Multimedia University, Malaysia. She completed bachelor's and master's degree in computer science and engineering from Andhra University, India, and he PhD from Curtin University, Malaysia. His academic journey reflects a deep commitment to excellence in teaching, research, and innovation. With extensive academic experience, he has been contributing to multimedia university Malaysia since 2018. Prior to this, served in various academic leadership roles, including as the head of the Information Technology Department at College IGS Brunei. Such interests span a wide spectrum of emerging technologies, including artificial intelligence, smart grid systems, cloud computing, big data analysis, data science, sustainable computing, and intelligent energy management. Through her research, she has consistently explored innovative solutions that bridge technology and societal needs. She has authored numerous publications in its prestigious IEEE journals, international conferences, and publications, making significant contributions to the clinical research community. She has also been actively involved in funded research projects and received several academic recognitions for outstanding scholarly contributions. We are honored to have our respected resource person, Dr. Palaniswamy Naveen, share her expertise and valuable perspectives on the latest development in trustworthy AI for cybersecurity, building intelligent, explainable, and resilient defenses. We are confident that this session will inspire fresh ideas, stimulate meaningful discussion, and encourage innovative research among all participants. On behalf of Bharat College of Science and Management, Autonomous Thanjavur, it is our great honor to extend a heartfelt welcome to Dr. Palaniswamy Naveen. We sincerely thank you for your acceptance to share your knowledge and experience with us. Ma'am, the virtual stage is now yours. We look forward to insightful and inspiring session. Thank you.
Now start begin the session one, ma'am.
Am I audible?
Yes, ma'am. Here.
Yep. Thank you, and good morning, everyone. It is a pleasure. Just a moment. Let me share my screen. Can you permit me to share my screen? I have sent a request. I would like to share my slides, but I need permission, so I sent you the request. Could you grant me permission? Okay, thank you. Just a moment. I hope you're able to see my screen.
Yes, ma'am. This is
Okay. Okay. So once again, good morning, everyone. So it's a pleasure to be here at Bharat College of Science and Management I sincerely thank the organizers for inviting me to speak at this international conference. Today we will, actually introduction was given to me. I'm Dr. Panishami Naveen. I'm the chairperson for Center of Digital Innovations and faculty member of Computing and Informatics. And today's topic is on trustworthy AI for cybersecurity. As we do know, okay, sorry. As an increasing topic is basically trustworthy AI for cybersecurity. In specific, artificial intelligence is transforming the way we defend digital systems. However, attackers are also using AI to launch more sophisticated cyber attacks. So this raises an important question. Can we trust AI to protect our digital world? Tomorrow morning, you're waking up, and if you check your phone or your bank account, it is empty, or otherwise your hospital records are being encrypted, or otherwise your organization's entire cloud has been hacked. Okay. So in this situation, would we trust artificial intelligence to protect our digital life? That's a question of topic. So today's talk is about answering that question, which is basically, I hope you're able to see this one. Okay. So why cybersecurity needs trustworthy AI? Today, almost every, what happened? Just a moment. Okay. So today, almost every aspect of life is connected to the internet, from smartphones and banking to healthcare and smart cities. As digital connectivity grows, so does the number and complexity of cyber attacks also grows. So traditional security solutions basically alone are no longer sufficient because attackers are using AI to launch faster and more sophisticated attacks. So this is where actually AI intelligence becomes a powerful defender. However, AI should not only be intelligent, it must also be trustworthy. It should make reliable decisions, explain its predictions, and remain resilient even when facing new and evolving threats. So that is the focus of today's session. So before looking into the trustworthy AI, so first let's have, already we do know, but maybe just let us know about the evolution of the cybersecurity. So cybersecurity has undergone a remarkable transformation over the past few decades. Initially, organizations relied on traditional security mechanisms such as antivirus and firewalls, which detected only known threats using predefined signatures. So then machine learning was introduced to identify the hidden patterns and anomalies in large volumes of secure data. This was followed by deep learning, which embedded systems to analyze complex behaviors and detect previously unseen attacks. So then at the present date, we do have the generative AI, which acts as an intelligent security assistant by helping analysts investigate incidents, summarizes threat intelligence, and automate security tasks. However, intelligence alone is not enough. We now need trustworthy AI, an AI system that are accurate, transparent, explainable, secure against evolving cyber threats. So artificial intelligence, as we do know, has become a powerful capability in cybersecurity. It is because modern attacks generate massive amounts of data that cannot be analyzed manually. No more manual analysis is possible. So AI helps security professionals in these major 8 areas. The threat detection is basically it continuously monitors activities and also identifies suspicious behavior. Maybe the example we could consider detecting unusual login attempts, a usual example. And the next, malware analysis, or otherwise malware classification. AI learns from the previous malware samples and identifies new variants such as ransomware. And AI, it also analyzes network traffic and detects possible attacks such as unauthorized access, which helps for intrusion detection. Also, it helps in banks use like to identify unusual financial transactions and prevent fraud. Likewise, in terms of behavioral analytics, maybe AI understands normal user behavior and detects abnormal actions such as employees downloading large amount of sensitive data likewise. Okay. Also, identity management, it helps, that is, enables adaptive authentication by evaluating user risk before granting access, like multi-factor authentication. And then security automation, it also supports in terms of security automation by supporting security operations centered by automatically analyzing alerts and responding faster. So these are basically how the AI cybersecurity transform digital defense. But it also has problem, like the case shown on the figure to the left-hand side. For example, imagine your bank's AI system suddenly blocks your credit card transaction. The system may be highly accurate, but if nobody can explain why the decision was made, users will lose or lost trust. Okay, so if this is a case, then consider about the hospitals, airports, then military or cyber. So all these, an incorrect AI decision can have serious consequences. So we cannot simply accept decision from a system that behaves like a black box. So hence, we come to the topic, basically the trustworthy AI. So basically, what is trustworthy AI? It means that AI systems should not only be intelligent, but also responsible and dependable. A trustworthy AI system must satisfy multiple requirements, like it should make decisions without unfair bias against individual or groups. So that is one of the important one, which is a fair. Then it must be reliable. AI should perform consistently and produce dependable results. Likewise, it should avoid harmful or unexpected outcomes so that it is safe and transparent and explainable. As we can see, explainable, as well as if it is explainable, obviously it must be transparent. So users should understand how and why AI makes decision, especially in critical applications. It should also be maintaining the privacy preserving. So protect personal and sensitive information during data processing. And it also should provide security in terms of protected from attacks such as data poisoning and adversarial manipulation, and also responsibility, that is accountable. There must be clear responsibility for AI decision and actions. So in cybersecurity, these principles are extremely important because AI systems are often used to make decisions that affect security, privacy, and trust. So when we do talk about the trustworthy AIs, as we have discussed why it is needed. And then actually, in order to ensure it is a trustworthy AI, then actually these are the pillars which we can't avoid. So the first requirement is a fairness. Before trusting an AI system, we need to ensure that its decisions are not influenced by bias. Already we have seen. So example, we could consider say, for example, imagine an AI system used for loan approval. If the training data contains historical bias, then the AI may unfairly reject certain applications. So an intelligent AI system must first be fair AI system. Next comes basically the next pillar is understanding the decision, which is explainability, which indicates why and how. Which is the second pillar is transparency and explainability. AI should not behave like a black box. If it behaves like a, black box, it blocks a user's account. Security teams need to know why it happened. What was it? Unusual behavior, a suspicious location, or possible attack? It must be able to explain it. So hence, normally explainability means why and how. So a decision that cannot be explained is difficult to trust. So, however, to explain decision, AI needs to access data. So this creates another important challenge, which is basically the next pillar, which is protecting information. Okay, so AI system depends on large amount of data, but this data often contains sensitive information. Example, healthcare records, banking transactions, personal identity information. So therefore, trustworthy AI must learn from data while protecting individual privacy. So AI should be intelligent without compromising privacy. Even a fair, explainable, and privacy-preserving AI can still be vulnerable to attacks. So having said all these three are important, the next pillar is defending the defender, which is it must be robustness. It should robustness and security. So attackers do not only attack applications and networks, they can also attack the AI model themselves. Okay. So like examples, adversarial attacks, data poisoning, unknown malware patterns are examples of those attacks. So AI system, which is considered as trustworthy AI systems, must continue to perform reliability even when facing unexpected conditions or deliberate attacks. So AI used for defense must also be protected. When AI makes decisions, an important question remains, which is basically who is responsible, which is accountability. If AI makes a wrong decision, who is responsible for that decision? Is it the AI developers or the organization developing AI or the regulators? Okay, so AI can assist decision making, but humans must remain responsible for the customers, okay, outcomes and the customers, decision on that. So trustworthy AI requires not only intelligent machines, but also responsible governance. So these are the pillars of the trustworthy AI. So however, to explain the decision, AI needs access to data. This creates another important, which is basically the privacy. Sorry. I was going back to the same content. So together, these 5 pillars transforms AI from a powerful technology into a trusted technology. So which is that this slide actually shows a comparison between the traditional AI and the explainable AI. As you can see on the left-hand side, basically in the traditional AI, we provide input data, okay? And then the AI model processes it internally and finally produces a decision without any explanation and without those pillars, the robust, all those things. And so this is basically the traditional AI. Say, for example, a cybersecurity AI system may classify a file as malware, but the security analyst may not know why the AI made the decision. Was it because of the file structure or network behavior or suspicious code pattern? So the reason remains hidden. So hence, actually, we do for the trustworthy AI, we are in need of this explainable AI, which addresses the limitation by adding an explanation layer to it. So instead of only providing a decision, not just the decision, it also also highlights the important factors that influence the decision. So a back to the same example, a malware detection system can explain that the file was classified as malicious because it contains suspicious API calls, abnormal network communication, and ransomware-like behavior. So this would be some, the reasons for that. Okay. So this explanation is important because cybersecurity professionals need confidence before taking action. An AI system that can explain its decision is easier to validate, monitor, and trust. So say, for example, on this right-hand side, you're able to see this sample, phishing email. Okay. Yep. So as you can see here, this email actually shows, as you can see that email address is basically this one. So in this case, it is basically the analyst, maybe they would, if they are using this, AI, then actually if it is going to be the traditional AI, then it will just predict it as a phishing one without telling the reason why. Whereas if it is the case of explainable AI, then it will be providing the reasons, the reasons or the features, why actually, the factors why it actually showed that it is, it was predicted as phishing. Like example, in this case, it was predicted as phishing because of suspicious link, unknown sender, urgent language, and fake domain. Okay, so basically the explainable AI, it does not provide just the prediction. Together with that, it also provides a reason. Just a moment, huh? So having known what is explainable AI, then these are the different techniques used in terms of explaining the decisions made by the AI. So the same email, and to the right-hand side, you're able to see the different techniques of explainable AI, while this line actually shows explain only one prediction, explains only one reason otherwise, which is basically because of one particular factor. So line actually stands for local interpretable model agnostic explanations. It explains a single prediction by identifying which features influence its specific decision. So suppose in this case, AI classifies one email as phishing. Line can show that the suspicious link and urgent wording were the main reasons for this. In this case, urgent, and then the most, as you can see in here, it's unknown sender. So according to this one, and the example, as you can see, the scoring urgent language. So these are the reasons why it predicted as phishing. So the next one onto this right-hand side is basically the SHAP. So it not just focuses on the, basically it rank feature importance. As you can see, the visualization is here. So for the same one, SHAP measures the contribution of each factor to the AI's prediction. So instead of explaining just one feature, it ranks the importance of all the relevant features. So in this case, actually, it shows that the fake domain contributes 50, the different percentage basically. So we could say 50% of the decision, while the unknown sender contributed 30%. So it shows the importance of, or the weight of each of it. So the next we do have the attention maps. It's quite different. So this is basically deep learning model that processes a large amount of information. So attention map highlights the parts of the input that the model focused on. Okay, so that is basically the attention mapping. And maybe, for example, when analyzing the email, the AI may focus on the malicious URL or suspicious wording. In image-based malware detection, it may highlight specific regions of the image. And finally, it's counterfactual explanations. So counterfactual explanations answer a simple question. That is, what would need to change for the AI to make a different decision? So how it could be, what would be the prediction if something is, some features or factors are changed. So that would be the counterfactuals. So if the suspicious, say for example, if the suspicious link is removed and the sender is verified, the AI may classify the email as legitimate instead of phishing, which is actually wrong. So the counterfactuals would help in explaining that. Okay, so each technique provides a different perspective. LIME explains one prediction. SHAP ranks feature importance. Attention map shows where the AI focused, and the counterfactual explanations explore how different inputs could change the outcome. So the common goal is simple: make AI decisions understandable and trustworthy. So explainability helps human understand AI decisions, but another important challenge remains still: how do we ensure AI systems remain secure and resilient when attackers deliberately try to deceive them? Which is resilient AI. So this brings us to the another important pillar of trustworthy AI, which is basically resilience. So resilience means that AI continues to operate correctly even when it encounters attacks, failures, or unexpected situations. Say for example, think of a bridge during say for example, a storm or a flood. So a well-designed bridge may shake under strong winds, but it remains standing and safe to use. In the same way, a resilient AI system may encounter attacks or abnormal inputs, but it continues to function. It should continue, continue to function correctly. So then it's considered as a resilient one. Say, for example, in autonomous vehicle, AI continue making safe driving decisions. Like in healthcare, AI should support decisions even if data is incomplete or noisy. And in terms of power grids, AI must keep monitoring and protecting essential infrastructure. Sorry? So in cybersecurity, attackers constantly evolve. Therefore, our AI system will also be resilient, adapting to new threats instead of falling when challenged. So normally, having understood the different, the resilience of AI, then just a recap on the different attacks. Basically, in terms of AI attacks. So we often think of AI as a tool for defending against cyber attacks. So far, that's what we have seen. But however, attackers have also learned how to target AI systems directly. In other words, AI is no longer just a defender. It also has become a target. So attackers, say for example, in the case of adversarial attacks, attackers make tiny, almost invisible changes to an input so that AI makes a wrong prediction. Example, a few stickers placed on a stop sign could cause an autonomous vehicle's AI to misclassify it as another traffic sign. Even in here, as you can see, original panda and the misclassified gibbon, like a small change in that. Okay. The next one in terms of attack is basically the data poisoning. So instead of attacking the AI after development, in this case, attackers manipulate the training data even before the model is built. So if the attackers inserted incorrect labels into a malware data set, the AI may learn the wrong patterns and basically there'll be a misprediction, a wrong prediction, okay? Because the model itself is trained with the wrong data. So the output will also be an wrong prediction. So model theft, AI models are vulnerable intellectual property. So attackers may try to copy or steal a trained model. So by having access to the model itself. So a competitor or cyber criminal replicates a company's fraud detection model without authorization. So then we do have prompt injection, which is basically the large language models follow user instructions. That's how the prompt actually works, isn't it? So attackers can craft malicious prompts to bypass safeguard or manipulate the responses. So as the attackers tricks an AI assistant into revealing confidential information or ignoring security rules would be an example for this prompt injection. The deepfake attack, which is popularly known, AI can generate highly realistic fake voices, images, and videos that are difficult to distinguish from real ones. So, example, a finance employee receives a call that sounds exactly like the CEO. So that would be an example. So these attacks show that AI itself requires protection. Building a resilient and trustworthy AI means securing not only our networks and systems, but also the AI models that defend them. So the next question, this leads to the next question. How do we defend AI against these attacks? Okay, let's explore the strategies for building secure and resilient AI systems. I hope you're able to see that. So basically, in this actually, where we can see everything starts with a trusted, high quality data, because AI, definitely we need data. So if the data is inaccurate, biased, or intentionally manipulated, the AI model will learn incorrect pattern, as we have seen earlier. An example, even to be more clear, an example would be a malware detection model trained on poison data may fail to detect real malware. We have seen that earlier. So having ensured that the data is secure, then actually robust training is required. So the AI model should be trained using diverse, representative, and balanced data set so that it can be generalized to real world situations. So sometimes if we don't have the representatives or the diverse varieties or the balanced data sets, actually generative AI could help in order to come up with the data so that we could train the model, so that we could ensure robust training and we could generalize to real world situations. Another example would be include different types of phishing emails, malware variants, and network attacks during training. Having trained the model, the robust training is done, then moving on to the adversarial testing, which includes, that is, before deployment, we deliberately test the AI against simulated attacks to identify weakness. That is, can the model still detect malware if attackers slightly modify the malicious file? So that is basically the adversarial testing. And then without stopping with the adversarial testing, it definitely needs continuous monitoring. So cyber threat evolve every day. So AI performance must be continuously monitored. It should not once it is, maybe occasionally we do know it's not the case. We need to monitor it continuously. So if detection accuracy suddenly decreases, security team should investigate it immediately. So human oversight, already we have seen, that is, it is not just a AI predict, it is basically supporting the human. So we need the accountability is required, right? So human oversight is required. AI should support human experts, not replace them. Critical security decisions should always involve human review. Example, if security operations center analyst validates high risk alerts before taking action. So that would be the one. So in this case, as kindly be clear that it is not the AI is making the decision. It suggests or it otherwise assists the operator, and the analyst or the operator makes the decision, the appropriate action for it. So having said, it must be continuous, otherwise resilience is not possible. Model updating is the important one in here, which is the final one also. AI model must be updated regularly to recognize new attack techniques and emerging threats. So a phishing detection model is retrained to identify the latest AI-generated phishing emails. So building resilient AI is not one-time task. It is a continuous life cycle, meaning the model will be need to be updated then and there. So it is a continuous one, from securing the data and training the robust models to monitoring, human oversight, and regular updates. Okay, so this is basically building the resilient one. So the next one, if we move on to, is basically the generative AI, as I earlier discussed about it. So earlier we did discuss about that AI can be trustworthy and resilient. Today, another major advancement is the rise of generative AI, which is changing how cybersecurity professionals work. So many of you are already familiar with the tools such as ChatGPT, Gemini, Claude, Microsoft Copilot, GitHub Copilot. So these are not cybersecurity products by themselves, but they can significantly improve productivity. So, like the generative AI could assist in terms of generating security policies, summarize threat reports. Then they could come up with security code review, explain malware, then security operator assistance, incident response. So all these ones could be done with the help of the generative AI. Okay, so in terms of, say, for example, security policies, generate security policies, instead of starting from a blank page, AI can draft security policies based on standards and organizational requirements. So from there, actually, we could enhance it. Okay, then in the case of summarizing threat reports, generative AI can summarize threat intelligence reports, making it easier for analysts to understand emerging threats. Again, here it assists in terms of explaining. And in terms of code review, developers can use AI to identify insecure coding practice and receive suggestions for improvement. Whereas in terms of malware explanation, rather than manually analyzing the complex malware reports, AI can explain malware behavior in simple and understandable language by any person. Any person in the sense who is responsible for that. In terms of SOC assistance, which is basically Security Operations Center, AI can summarize alerts, correlate events, and support analysis during investigations. And also incident response. AI can recommend response steps, helping security teams react more quickly. However, generative AI is also not always correct. It can produce inaccurate information, hallucination facts are there, or overlook important security details. So researchers started to work on how to measure the hallucinations and whether to rely on whether the suggestion provided by the AI is reliable or not. So research are currently focusing on that. Say, for example, this sample in terms of an example scenario, which I have done earlier using ChatGPT. So the prompt here given, I have provided a sample email in this case, and I want to I want the ChatGPT to explain and let me know whether it is a phishing email or not. So that is a prompt, and the sample email is given. And if we do provide it, so this is the result from the, basically ChatGPT. So it shows how it is analyzed, and then also the conclusion, and also what would be the recommended action. So this is just an example for assistant. So having gone through this one, the SOC, the concerned person, should not completely rely on it, need to verify it, and then actually need to take the appropriate action. So the AI analysis, as you can see here, it shows the details on what basis actually it came to the conclusion that it is a high level of risk. Okay, so this also helps in one way to avoid it. So generative AI is most effective when it works alongside human expertise. AI speeds up analysis while human provide judgment, context, and final approval. So future of having known all those things, then what about the future of the trustworthy AI? So we have explored whether a trustworthy AI stands today. Now, this one is about the future of that. So in terms of that agentic AI, today's AI usually responds to prompts. The next generation, which we do call it as agentic AI, will be able to plan, reason, and perform multi-step cybersecurity tasks with minimal human intervention. Whereas in terms of autonomous SOC, that is the concerned person, that is the Security Operations Center, will increasingly use the AI to automate routine investigations, correlate alerts, and assist analysts in responding more quickly so that the faster response will be there. So AI augments analysts rather than replacing them. So the next one in terms of the safer AI would be the federated learning. Organizations can collaboratively train AI models without sharing their raw data. So this improves privacy while still benefiting from collective learning. So say, for example, in terms of hospitals, they could improve cyber threat detection model without exchanging patient records. So between the hospitals, basically. In terms of privacy preserving AI, AI uses more personal and sensitive data, as we do know. So protecting privacy will become even more important through techniques that reduce data exposure. So quantum safe cryptography, which is coming into light. It's popular. So quantum computers may one day break many of today's encryption methods. Organizations are preparing by adapting cryptographic algorithms designed to resist quantum attacks. So that is basically the safer AI. Then the responsible under the responsible AI, it is basically the AI governance, responsible AI, zero trust architecture. So AI governance is basically the technology alone is not enough. Organization need policies, standards, and the risk management and oversight to ensure AI is deployed responsibly. And responsible AI, it ensures that AI systems remain fair, transparent, explainable, accountable, and aligned with ethical principles. And also, the cybersecurity principle of never trust, always verify also applies to AI. So every user, device, application, and AI interaction should be continuously verified. So when we do say AI, trustworthy AI, it includes intelligent, explainable, resilient, and responsible. So this brings us to the final message of basically today, how we can build digital defenses that are not only intelligent but also explainable, resilient, and trustworthy of our trust. So basically, in conclusion, artificial intelligence will not replace cybersecurity professionals. It is basically should assist. So cybersecurity professionals who effectively use AI will have a significant advantage over those who do not. So basically, the conclusion is that it is we have to use the AI as the trustworthy, even though it is a trustworthy AI, we have to use it as an assistant, and the decision should be always done by the security professionals. So that's it for me for today. And thank you for giving me this opportunity.
Thank you, ma'am, for the insightful presentation. We will now have a live question and answering session. Participation may post their question in the chat box.
Thank you for the question. As I did mention earlier, we do have the explainable AI. The question is, how can organization ensure AI systems secure and trustworthy? So as I addressed earlier, research work actually still it's in progress. Hallucination studies are there using RAG models. So by that, actually, we could ensure. So soon that would be addressed. At present, we are still working on, as everyone does know about it. So explainable AI could help on that. And then in addition to that, actually, hallucination studies would also help to ensure that it is secure and trustworthy. I hope I answered your question. Yes. That is why we need to, as we have seen on the previous slide, it has to be monitored then and there. Continuously, it has to be updated. Yes, hackers can. Can explanations generated by AI ever be misleading or incomplete? As I did mention earlier, we need to consider AI, whatever the suggestions provided by the AI, as it is basically an assistant. So that's why human insight, oversight is required. The decision has to be made by the human. It can assist, we could consider that as an assistant, but not as a decision maker. Definitely, it might be misleading. If it is URL based, yes, as I shown you earlier, we can use even the ChatGPT models, ChatGPT or other models to detect whether it is a phishing email or not. If it is just based on that, yeah. Thank you for the valuable questions. I hope I answered it. My explanations were clear to you. Sorry, I didn't see the question. Sorry. What was it? What is the problem in cybersecurity in hospital sites? Basically, in terms of our records, which are sensitive information, right? So that would be the main problem. And apart from that, some interruptions would be there, right? So these are the ones.
Thank you, ma'am. Thank you for your valuable question and answer, ma'am. Now I invite Ms. R. Agalya to introduce our second resource person.
Respected Secretary, distinguished dignitaries, esteemed faculty members, researchers, students, and participants from India and abroad, good afternoon. It is my distinct privilege and honor to introduce our esteemed resource person for today's International Web Conference. We are delighted to welcome welcome Dr. A. Usharani, who is currently serving as an assistant professor in Department of Computational Intelligence at SRM Institute of Science and Technology, Katangulathur, Chennai. With more than 20 years of experience in academia, research, and industry, she has established herself as a distinguished educator, researcher, and mentor. Her research expertise encompasses artificial intelligence, machine learning, deep learning, healthcare data analytics, natural language processing, data science, and cybersecurity. Her work focuses on developing intelligent and trustworthy AI solutions for real-world challenges, particularly in healthcare and secure computing. Throughout her remarkable career, she has served in several prestigious institutions and guided real-time projects for leading multinational companies including Wipro, HCL, Mindtree, and Cognizant. She has also been associated with PITS Pliny as a guest faculties and project dissertation evaluator, mentoring students and researchers in cutting-edge technologies. Dr. Usharani has an impressive research profile with numerous publications in internationally reputed journals including Discover Computing, Scientific Report, Soft Computing, the International Journal of Machine Learning and Cybernetics, and several Springer and IEE conference proceedings. She has also contributed book chapter, patents, and innovation research in artificial intelligence, cybersecurity, healthcare analytics, and quantum computing application. Her academic excellence has been recognized with the Best Research Paper Award 2021 to 2022 from the Nature Science Foundation. Furthermore, she served as a reviewer for reputed international journals and is the lifetime member of IEE, IEI, CSTA, and IAENG. Today, she will sharing a valuable insight on the latest advancement in explainable artificial intelligence, resilient AI system, security, and language intelligence. We are confident that her expertise and practical experience will inspire all participants and enrich our understanding for these rapidly evolving research domains. On behalf of Bharath College of Science and Management, Autonomous Thanjavur, I extend our heartfelt gratitude to our resource person for graciously accepting our invitation and sharing her valuable and expertise with us. We warmly welcome our distinguished resource person, Dr. A. Usharani. Now, I invite our esteemed resource person, Dr. A. Usharani, ma'am, to take over the section. Ma'am, our virtual platform is now yours. We look forward to enlightening and inspiring section. Thank you all for our kind attention. Have a wonderful learning experience.
We now start the second session, ma'am.
Good afternoon to everyone. Am I audible? Am I audible? Thank you, Sadish. I'll send the request to share my screen. Can you please? Thank you. Can you see my screen? Thank you, Rohit. Excuse me. Good afternoon to everyone. First of all, I would like to express my sincere gratitude to the Bharath College Secretary, Strategic Head Director, Principal, and IOAC Director, and the Department Head, Mrs. Sumitra, to organize this wonderful international webinar, and extends my sincere thanks to all the participants. Shall we start the session now? Thank you. So today in this webinar, we are going to share our knowledge related to explainable artificial intelligence in natural language processing concepts, techniques, applications, and some of the hands-on Python programming demonstrations also we will see for our understanding purpose. Okay. This is Dr. R. Usharani, Assistant Professor, Department of Computational Intelligence, SRM Institute of Science and Technology, Katamulathur. These are all our learning objective in this session. By the end of the session, we will understand the evolution of NLP, that is natural language processing, and the need for explainable AI. And we can explore major explainable AI techniques. What are all the techniques available in XAI and their applications in natural language processing side. And we can implement explainable some of the techniques to interpret natural language processing models using Python at last. So we can start the first objective, understand the evolution of natural language processing. Then only we can understand why we need explainable AI. So natural language processing is a branch of artificial intelligence. It enables the computers to understand, interpret, analyze, and generate human languages. So in our traditional programming, what we are doing, using some conditions, rules, and techniques, we are doing all the coding and interpreting using our input, and we can get our output. But nowadays, we are using machine learning, deep learning, and artificial intelligence related techniques, which will helpful to make our computers to learn. Okay, so it can learn like a human being and understand, interpret, analyze, generate human language side, that is natural language processing. And why explainable AI here? So first we need to understand what is explainable AI. It's a set of techniques. It enables humans to understand, interpret, and trust the decisions made by the artificial intelligence or machine learning models, which means nowadays we are working with machine learning model. Let us assume whenever we feed our input, any COVID related data set or any healthcare related data set, diabetes data set, or any other financial data set, if feed these data set, whatever the data set contains the features, let us assume the Excel sheet contains features are nothing but COVID related means cold, cough, and the blood test report. Diabetes related means glucose, HbA1c test report, glucose tolerance test, their age, person age, obesity, like these are all the features. Along with the features, we have some output also, whether the person has diabetes or not, COVID or not. Like that output also we have in this Excel sheet. In traditional programming language, what we are doing, we feed our conditions, interact with our healthcare department domain experts, and what are all the conditions needs to set these criteria. We feed all the criteria through our programming languages like Java. Then after that, we can make the decisions using through the conditions. But this machine learning algorithm, how it differs from traditional programming language. Here we no need to write these conditions and decision making rules. We no need. So what we are doing here means, let us recall our example that Excel sheet contains diabetes related or COVID related input features as well as output also available. So if we feed these inputs to the machine learning algorithm, then what it's doing means it learned the patterns. How the doctor learned the patterns, we already discussed with the domain experts. All the patterns given in the Excel sheet, features, the limitations, everything is there. So those who suffering diabetes or COVID, which features are contribute to lead this disease. So this is done by the pattern learning is done by machine learning algorithm. How it is possible? Which is nothing but, let us assume in our calculator we are typing 2 plus 3, then we can get 5. Similarly, when we press the remote control, we can change the channels and all other features in our television. Similar, how it made? So the background behind that work, what it is, some techniques are there. Similarly, however you are doing Java, for example, whenever tossing the coin, we have studied the statistic learning, what's the chance to get a head or tail. This we have already studied in our school days also, in our mathematical statistical learning. Here, what is the chance to get head or tail whenever tossing a single coin? Similarly, whenever tossing a 2 coin, what's the chance? What's the chance when rolling the dice? All the probabilities and chances we can get through the statistical formula, naive Bayes algorithm, isn't it? Bayes theorem. So that naive Bayes theorem, each and every interactions and iterations already predefined in the machine learning. That is machine learning. So whatever we have in the statistical learning formula in naive Bayes algorithm, which is predefined. Linear regression formula, y equal to ax plus b. What's the concept behind this? Everything is predefined. So whatever we have already in programming languages, but we need to do the formula oriented coding, but now not required. All the packages and the libraries are available already. We can import all this library. It will learn the pattern. So we are instructing the system or computer to do this pattern analysis. So machine learning in artificial intelligence helpful to make these decisions. Okay, that is machine learning model, how it differs from traditional programming language. Hope you understood. So next, how are natural language processing and explainable AI connected? So natural language processing models understand and process human language. Let us assume nowadays we are using translation, English to Tamil, English to Hindi, Hindi to English, like that. Translation and paraphrasing and several grammar checking tools are available. So this side we are going to concentrate in explainable AI in this webinar. So after understanding these things, what are all the explainable AI techniques available and how we can use in NLP side? I will demonstrate some of the simple programs. After understanding these, you can use the same techniques, explainable AI techniques in different field also possible. Why? Because after understanding the working principles of some of the techniques in explainable AI, you hope you all understand after the demonstration, you can take these techniques into your own different domains are also possible. So for our understanding purpose and 1 hour webinar, I am choosing the NLP, how to adapt these explainable AI and improve their decision making process. Okay. So first understand the evolution of natural language processing first. Initially, the rule-based algorithm working then NLP. After that, machine learning introduced. After that, deep learning introduced. Then we get transformer models. Why? Every stage improved the performance of natural language processing system, but also in every stage introduced new challenges. So to overcome these new challenges, they introduced machine learning. After that, whatever in new challenges occurred, to overcome this, introduced deep learning. Next, transformer models. Like that, next we can adopt all these things with explainable AI. How it is? So rule-based natural language processing, how it will work? The working principles. Let us assume you have one movie. You want to create one movie review. Okay. Excuse me. Okay. You want to create a movie review or any customer review like that. All the movie related informations already you have seen. Similarly, in the PDF document, let us assume movie related informations are all there. So you are going to create the movie review either positive or negative side. So what you are doing means, after seeing all these features or movie or any product related, you set some of the conditions with this. If you see these conditions, then you can fix it with excellent, good, or happy. If you see, for example, the document contains along with excellent, the word excellent, good, or happy, then you can decide with positive. If the documents contains product related document, or movie related document contains some bad, damaged, poor related, then you can set these are all as negative side. So these rules making using rule based techniques. So the computer simply follow these predefined rules only. Then the advantages of rule-based systems are easy to understand, completely transparent, every decision can be explained, easy to debug also. But the limitations here is, here they had some significant limitation. For example, if the document contains the sentence, the phone exceeded all my expectations. Here the word excellent not available, the word good not available, the word happy does not appear. So you have already feed all these things only. Apart from that, any sentences or any other words are there, it cannot predict it, because it simply follow the whatever predefined rules you given. So a rule-based system may fail to recognize this as a positive review or negative review. It cannot do it. So we need the transition from rule-based NLP to machine learning. So why we move to machine learning? So we realized that manually writing rules for every language domain and situation was impractical. So we make our computers to learn patterns directly from many data, large amount of data. This led to the development of machine learning based natural language processing. So how rule-based system working? This pictorial representations gives us the working principles. We feed the input raw data. Here the handcrafted rules are there. For example, if symptom is fever and cough is yes, then diagnose flu, like that. So the output we can get decision result. On the other hand, if you use machine learning algorithms, then we can feed the large amount of data as an input. The machine learning algorithms learns the patterns and make the predictions that analyze the pattern. Whoever falling or leading to this disease, what features are contribute to lead this disease. It analyze how we are analyze your results. After getting your results, first year students, how many students participate in this exam or sports like that. We are analyzing the results based what are all the category of people in this side and that side like that we are analyzing after that giving the output. Similarly, it analyze all the patterns, how many features are contributed importantly to lead these disease or any output related. It recognize and give the predictions or decision or classification like that. So machine learning algorithm doing like that. So for example, we can consider we are setting the information excellent, good, great like that. Similarly, negative side, we are setting bad, poor, broken, damaged, product related something, any negative words we given. But in the training period of the machine learning algorithm, it learns all the patterns and also it learns the meaning of other words also. So excellent equal to great, amazing, wonderful, fantastic. All these are similar meaning. What's the context behind this? So it collect thousands of labeled examples and after that it will make the prediction or classification like that it is in the side A side, B side or good side, positive side or negative side like that. So whenever after training the model using machine learning algorithm, if we give the test data, apart from that, whatever training we have feed, some more different informations are also available in the test data. The NLP doing good for the test data also, which is differ slightly from the given trained examples. So compared to rule-based machine learning algorithm, which is best. But still we have some limitations whenever using machine learning. But it learns a context, not just individual words. The machine learning algorithm doing it. Let us consider this example, the sentence. The phone is light, the room is light. What's the meaning and how the sentence differ from one another? The phone is light means easy to carry. That is positive side. The room is light means it refers to brightness, not weight. Phone depends with easy to carry, it depends with weight. But the room is light means it refers to brightness only, not refer like the previous sentence light. So we need to concentrate context also, surrounding. So remember, a rule-based system sees the same word, but the machine learning model, it accepts the similar different words also to predict good, but it has not seen enough examples like the phone is light and the room is light like that. So we need next transition. So we deep learning model introduced. So here deep learning model uses surrounding words like phone and room to understand the correct meaning. What's the difference between phone and room? So room related context, light refers to brightness. Phone related context, light refers to easy to carry. So it can be done using through the deep learning model. Okay, the pictorial representations tells us the same. Look at the picture. Here input text document feed feature engineering need machine learning model. We need to give the feature engineering manual, which means what are all the words and the different words may occur. From the document, the machine learning algorithm can learn. Some of the machine learning algorithm, logistic regression, support vector machine, etc. We can use it here and we can get the output. But the manual features and domain knowledge may struggle with context and ambiguity. We already seen phone is light and room is light. But on the other hand, if we are using deep learning network, it learns features automatically. We no need to give the difference between excellent, good, and any other new words. Large amount of sentences, training samples, if we feed, it can take us an input and automatically learns features and context automatically. and it will give the prediction as a good one compared to machine learning algorithm. So it learns complex representations automatically, understand context, and handles ambiguity better. So therefore, we need deep learning. So what are all the methods available here? Here, the recurrent neural network, long short-term memory, gated recurrent unit. These are all the example techniques involved here. So how it will work? The working principles of recurrent neural network. It processes the text sequentially and it remembering the information from the previous words. Whenever we are typing in Google search engine, what is natural language? After that, some of the words automatically will come processing, and whatever words already typed by the user, it can remember this information from the previous typing. But it is suitable for recurrent neural network is suitable for only short sequences. If we give long sequence sentences, it cannot do the operations better. This phenomena is otherwise known as vanishing gradient problem, which means long sentence is there, it cannot remember the previous starting sentences, some words in the previous sentences. So it can suitable for only short text classification, language modeling, simple sequence prediction. The limitations, it cannot effectively capture long-term dependencies in long PDF documents or paragraphs. So the software engineers introduced LSTM method, long short-term memory. It has some memory cells. That's memory cells uses to store and remember the previous informations. So long sequences while forgetting irrelevant details. Here, the memory cells used to remember this. The vanishing gradient problem, that is forgetting previous information, which is not occurring here. In LSTM, overcome this vanishing gradient problem. Here, the LSTM memory cells store the relevant informations only and forgetting irrelevant details. So it can be suitable for machine translation, speech recognition, document classification, healthcare in NLP side or any other domain also you can use it. The limitation here is more computationally expensive and slower to train than RNN. And this is also sequential sequences only it learns the patterns sequentially. And the next one, GRU, gated recurrent unit. It's a simplified version of LSTM. With fewer gates are available, it making it faster to train while capturing long-term dependencies effectively. So it can be suitable for real-time natural language processing applications like chatbot, mobile artificial intelligence, language modeling, etc. Limitation is slightly less expensive than LSTM for very complex sequential tasks. But all are sequential model only. There are no parallel related gathering informations are not possible. So we need another transition. We have already seen transition from rule-based to machine learning to deep learning. Now we need some other transition also. Why? For example, suppose the model predicts from the healthcare report, prescription doctor given to the patients, that time the prescriptions contains history of the patients also, past history, which is written by the doctor, domain expert. So that history, like a PDF, we have the past 1 year history for the diabetes complication patients, like that any other. So suppose the model predicts using deep learning algorithm or RN and something else we are using, cancer detected, okay. So it learns the pattern and if you feed the image or text, that time it learns the pattern and it will predict and cancer detected from these features. But doctor asks why the model cannot clearly explain, which means what's the reason behind this one? How it predicted all these things? Millions of neural network parameters contribute to the prediction. Human cannot easily trace which words influenced the final decision related to NLP. This is the beginning of the black box problem. Okay. So we need some transparent and overcome the black box. Black box means what happening in behind. For example, some placement related companies coming to your organization, taking some of the people. You want to all other people's selected people's, then all other people want how the criteria set. What behind this? Why these peoples are selected? Why these peoples are not selected? That reason we need. Similarly, now the time deep learning predicted or classified better. But how? What the reason behind this one? Doctor want to analyze what behind. This is black box only. So we need some transparent explanation for that. Suppose if we are a patient, we are asking the question to the doctor, na, why I am getting this? Then only we can avoid some food habit or we can introduce some new exercises, lifestyles are possible. So we are asking the question why, how, when, like that. So that explanation we need. Therefore, we are entering explainable artificial intelligence in any domain, not only the NLP. Previously, our other guest also explained in network side, security side. Now we are discussing in natural language processing side. You can use it in any other domain also possible. Before going to understand explainable artificial intelligence, we need some more clarifications about transformer models. Why we need a transformer models? What it is? The transformer model can process longer documents in natural language processing side more efficiently. The techniques are self-attention, parallel, and that is transformer introduced self-attention, parallel processing, and better context understanding. What it means? Previously, we have seen RNN, LSTM. RNN cannot remember the large amount of previous sentences what we have like that. So we need LSTM and GRU also we have seen, but all are sequential only, not we have parallel processing, those techniques. And they are difficult to understand the context surrounding the words. For example, what's the different meaning? Different sentences, how it produce the context related to COVID or health, any other healthcare, any other the word. For example, let us take one example. I'm sitting near river. I'm sitting near bank. Let us assume from this sentence, some of the people assume, okay, she is sitting near the SBI bank or IOB bank, like that financial institutions. But let us assume the bank not only represent these financial institutions. The bank represent, it may be a river bank also, na? River bank means what? The river, two sides we have the bank. Here the people can sit, isn't it? So I am sitting near river bank. If I am saying, then the people can understand easily. But the word only I am saying, I am sitting near bank. So many people, some of the people can assume, okay, she is sitting near the financial institutions, SBA, IOB related bank side. Some other people can assume she is sitting nearby some river bank sides. So it make the confusion. We need attention of the word sitting near bank. Bank context understanding, the surrounding words, what it says in this sentence. So parallelly, it processes several documents meaningfully. We need to give the attention of the important words from the given sentence. How? I am sitting near bank. So here the bank is the word we need to concentrate more attention onto it. So then only we need the transformer model. It will give the self-attention, parallel processing, and better context understanding. So what are all the models available here? How do we use it? The BERT model, Roberta model, and GPT model. Okay. So this pictorial representation, how we have seen the transition from deep learning to natural language processing requirements and need, and how NLP transformers helpful to predict the sentence. The room is light, the phone is light, I'm sitting near bank, like that. Okay. So what are all these models? BERT means bidirectional encoder representations from transformers. The expansion is this one. Roberta expansion is robustly optimized BERT pre-training approach. And GPT, chat GPT we are using now. GPT means generative pre-trained transformer. What are the difference between them? So the BERT can understand context by reading text in both forward and backward directions. So we can use it, question answering system, sentiment analysis, text classification, these situations. And Roberta is nothing but the next version, optimized version of BERT. So it achieves better accuracy compared to ordinary BERT. And such as text classification and natural processing or other, we can use it, Roberta is possible. And the GPT, we are all know about that. Generates coherent and context-aware text by predicting the next word in a sentence. So it can be used widely used for chatbots, content generation, summarization, code generation. All we can get it. Python code we want, we can get it. But we can use ChatGPT and other online resources, Cloud and other thing. But we our side is hope we need to take some help from these online resources. We are all the manager, owner, but if we are not understanding the concept, what we are asking, what we are going to do, just we are asking that information only, these online resources owner of ourselves. It own all the people. It own you. Don't allow it own you. Allow as a helper. You are the owner. Okay, so we can use all the online resources but properly. So all these techniques in deep learning transformer models helpful to do these natural language processing, text classification, sentiment analysis, question answering system, text generation, code generation, summarization, everything is possible using these techniques. So the advantages are better for long range context, faster training, large scale language understanding, but still we have some limitations. Suppose the model becomes even larger, BERT contains hundreds of millions of parameters and large language models contains billions of parameters. Okay, what it means, what we need, let us assume now. For example, if we give the input as a clinical, large amount of clinical report, several patient clinical report as a PDF, then the AI model predict cancer detected. The prediction is available, but the reason is not available. How you predict? What's the reason behind this? Which features are contributed here to lead this complication? Doctor can say, because you have continuous cough and cold for past 15 days. The test report also tells us you have COVID positive. Like that, the doctor says, no? But here, AI model, we can say 85 percentage, 95 percentage of result produced. We understood and accept it. But the reasoning is where? whether even negative or positive. Similarly, input feed from customer review in product side. AI model give this product is not good, negative comment. Why? Nobody knows. Which features and customer review from the document, many customers reviews are there. This product is not good, AI predicted, which is also correct, but how and why? Nobody knows the working principles of this one. What's the explanation behind that one AI? I'm asking the AI model now. But which is the reasoning is not available in AI model hand. This creates serious concerns in healthcare, financial side, recruitment side, legal system side, network security side, and so on, where every prediction must be justified. So we need that justification. So understanding the black box problem. Whenever we are using machine learning model or deep learning model, it produces highly accurate predictions, but its internal reasoning remains hidden from the users. So how to overcome this black box problem? This can be overcome by explainable AI. Now only we are entering this webinar, explainable artificial intelligence. Not only the natural language processing concepts. Why I am taking this natural language processing only? Some hands-on related to natural language processing side, some explainable AI techniques. Hereafter, I will use how to do otherwise how it will work. Explainable AI techniques. I will explain. So I need some domain. I am choosing this natural language processing concept. So you can use the same explainable AI techniques in anywhere is possible after understanding the working principles. Okay, we will see. I will start now. Actual webinar concept is starting now. So transition from transformer models to explainable we need, because we need the explanation. How do you predict this one? So the need for explainable AI, we need to understand. And what is explainable AI? What techniques available here? So the black box AI versus explainable AI, we need to understand from some of the techniques. So theoretically, we can explain all these things, but how? What are the techniques available here in explainable AI? If we see some of the techniques, we can understand how it will work, working principles and other things, then we can implement practically is possible. Therefore, we have some hands-on. Please be attentive now. So what are all the techniques available here in explainable AI? Some of the techniques I want to introduce: line, shape, attention, visualization, integrated gradients, occlusion. So some hands-on Python demonstration we will see using line and shape. Okay. So hope you all understood why we need explainable AI. So all the machine learning, deep learning algorithms, predictions are good. But what the reason behind this? Give me the explanation or your decision. The application. So we need explainable AI. This needs has led to emergence of explainable artificial intelligence, commonly known as XI. So explainable AI is a branch of artificial intelligence that develops methods and techniques to make the AI models understandable. Whatever AI models, machine learning, deep learning models already made the decisions, that decisions more understandable, transparent, and interpretable humans, we need this XI. It helps humans to understand how and why an AI system arrived at a particular decision. Unlike traditional AI models that only provide predictions, here XAI also provides explanations for those predictions. Okay? These are all the difference between traditional AI and explainable AI. Traditional AI gives only the prediction. Explainable AI gives the prediction and explains the reason. And the traditional AI focus mainly on accuracy. How much accuracy we got whenever feeding the diabetes data set to the machine learning algorithm. It predict 90 from the data set. 95% of people suffered from this disease. So 95 is accuracy. Why 5 we can't get it? Whether the data set problem or some more difficulties are there, how we can improve the accuracy, all are possible whenever using traditional AI. But on the other hand, it focus on both accuracy as well as transparency. Why we get this decision? It can be possible using explainable AI techniques. So in traditional AI, difficult to trust in critical applications. But whenever the explanation is given by the doctor, like that the explanation given by the AI, easier to trust and validate. In traditional AI, internal reason is hidden, but explainable AI, how all are important factors influencing the prediction. Excuse me, sound noise is there. Please mute yourself. Excuse me. Please, the host mute participant mic, please. Can I contact the host in this meeting?
காசு ஆனா எங்கேயா போவியா வாயா அப்படின்னா
Sorry. Please, the host mute the participant's mic. Here I can't do it. Can you hear me now? Rejoining possible now? Shall I continue? Please let me know. Shall I continue? Can I continue? Yes. Okay, thank you. So, hope you all understood why we need explainable AI. So, transition from transformer models to explainable AI, we are learning. So, here the example is, let us consider the clinical report. The patient has a malignant lung tumor with rapidly growing abnormal cells. The biopsy confirms invasive carcinoma. The AI model predicts cancer detected from the given document. So without explainable AI, the doctor only receives this prediction. So now naturally the doctor can ask, why did the AI predict cancer from this document? Which medical terms influenced the decision? Did the word malignant contribute more than the word tumor? Was invasive carcinoma the strongest indicator? All these questions asked by the patients as well as doctor. Technically, the doctor can ask this question. Patient also asks the question, why this carcinoma affected? What's the reason, if any heredity or which feature you seen from the report, blood test report or something else. So the AI cannot answer these questions. So we need explainable AI, how you predicted cancer from the document. Now imagine the same prediction with explainable AI. The system highlights the word malignant and tumor, abnormal cell, invasive carcinoma. So these are all the important words from the document. This is simple sentences only, paragraph only written here. But let us assume, which is a large document, past patient history is there, all the test report, blood test report, MRI, everything is written in the like a PDF, let us assume. So that patient history, the explainable AI can concentrate the important words malignant, cancer, tumor, abnormal cell. So what's the context behind this? It can ask all other surrounding informations, what it represents, what's the other meaning of these things. So it also indicates how strongly cells each term contributed to the prediction. So it gather all these informations and explain these are all the important words or features contribute to lead this disease. It can say the explanation. So now the doctor or patient can understand both the decision and the reasoning behind it is possible. So it make it easier to evaluate and trust the AI system. So now transition from transformer model to explainable AI. Why? Hope you all understand. Now, how do AI models generate these explanations? Using these techniques: line, shape, attention visualization, counterfactual explanations, saliency map, and integrated gradients. So what is line? It is local interpretable model agnostic explanations. How we can use it in our natural language processing related predictions. We will see after a few minutes with the demonstration Python coding in Google Colab. So line can explain one prediction at a time rather than explain the entire model. The word interpretable in that is local interpretable model agnostic explanation. Here the word interpretable meant by the explanation is simple enough for humans to understand. So finally, the model agnostic means line can be applied to almost any machine learning or deep learning model without modifying the model itself. We no need to change the model at our hand. It can give some of the random context surrounding the word, meaning of the sentences, everything. So it can give the better answer and explanations are possible. So we will see later how do we implement this line in our Python. So instead of trying to explain the entire model, line focuses on explaining only the current prediction. Let us assume we want to understand why the doctor prescribed a particular medicine for one patient. We don't need to know every medical decision the doctor has ever made. You only need to understand this one decision. Line works in a similar way. So we can apply this line into medical diagnosis, sentimental analysis, spam detection, legal document classifications in law side, fake news detection in newspaper article side, customer review analysis in product and movie side, financial risk prediction in financial side. All we can apply this line. So prediction made by machine learning or deep learning algorithm, explanation can give by this line is possible by the use of XAI techniques. Okay. So even if we have several advantages when we are using line, it has several disadvantages and limitations also. It's powerful, but it local explanations only. It prediction at a time. It does not explain the overall behavior of the model. So randomness introduced here. That is because line generates random perturbations of the input. That the explanation can vary slightly between different runs, which means we have seen one example. I'm sitting nearby bank. I'm not giving the word river bank or financial bank institution like that. I'm sitting near bank. So randomly it can give surrounding words. It financial or river, something else, randomly it will join with the given document. So the approximation will simplified surrogate model only. Is any other representations or meaning depends on the bank other than financial and then river. Is any other meaning is there? It cannot. Whatever document it sees and capturing and analyze the pattern, that can possible only. But apart from that, several different contexts are there. It cannot predict. It cannot do the work properly. And computational cost also very high. So we need to move some other technique. Now the development of shape. So it overcomes some of the lime's limitations. So shape means shapely additive explanations. So the shapely what it doing means it fetch all the important words and then context, and it will give the rank also. Rank means, for example, let us assume one example, the placement coming from IT side, Wipro, HCL, like that placement want to approach your college. Similarly, military organization, Jacob, like that something is there. They want to take some software engineer for military side organization. Why I am saying this example means we cannot set the same features important for all the domains, which is not applicable. Let us assume in IT side, your CGPA, grade, mark, your certification courses, these are all the important features. Then medical field also there. They want to recruit software engineer, then medical fitness, yes or no is enough. On the other hand, let us assume military side, Jacob corporation wants to take software engineers. In military side, army side, even if they want to recruit cook, driver, or software engineers, they need some height and weight measurement. Not only physical fitness, yes or no is not enough. Sports certification, any sports certification you have, medical fitness, whenever the large shoulder broadness and other thing is there now, because even cook or driver face any critical time in their job period. They need to train with the rifle, uh, pistol, and some of other tools, and how they secure themselves and others. So they need training. So they give the importance not only your grade. Here the mark may be the person attain only average mark, but the sports certification and the swimming certification and what is the how do we handle the pistol and other things, certification is there, training proof all we have, then they recruit as a software engineer or driver. So medical fitness, yes or no only, not enough in this army side, even if they recruit software engineer. So now what all are the important word from this your resume? Only in IT side, your CGPA and your other things, certification courses, how you completed, similar things they concentrate. They concentrate and give more rank for these features. Less rank for medical fitness. Yes or no is enough. On the other hand, army side, they want to recruit you as a software engineer, but they concentrate not only the CGPA, pass mark is okay, because they need sincerity and then regularity. So pass mark is okay. After that, sports certification is there, swimming certification is there. You can do the rifle and handle all these things. Okay, you are selected. So medical fitness is or no only, none here. Some other features has the highest ranking compared to your CGPA and certification courses. So this rank. Similarly, your resume is a PDF. So depends on the application. We want to make it, which one is the important features. The shape can do this. It understand from your resume. If you give your resume, frame your resume properly, not in the simple word, not elaborately, properly, accurately, if you give with the certification course belong to this one, I have this I have completed this course, I have completed these trainings, I am capable of these things accurately. If you given in your resume, then the shape can analyze all these things with context, then it separate properly for IT field in Wipro institution side and then army side. How can we give the important for which features? The shapely additive explanations shape can give. So how much each feature contributes to the final prediction? You are recruited as a software engineer in army side. You are recruited as a software engineer in MNC company side. So shape fairly distribute the predictions among all input features based on their individual contributions. So can every feature receive a fair and mathematically justified contribution score? Can we answer this question using shape? Yes, shape answer this question. For example, another example also, suppose imagine a cricket match. Suppose India wins. Who deserve credit? Batter, bowler, wicketkeeper, fielders. Everyone contributed differently, isn't it? So similarly, the AI model features contributes differently to the prediction. These words, how participated, where are the sentences nearby these, what context, what's the meaning of this, all can calculate using shape and contribution of each feature by considering all possible combination of all other features. Every feature receives a fair contribution score. It is known as shapely value. We will see later shapely value, how can we get it using Python. So hope you understood by the difference between line and shape. So for time consuming process, later we can go some fast manner. At the same time, we need, can the model itself indicate which words it is focusing on while processing the sentence? Now, interestingly, now we can adapt with the previous, we have seen the attention transformer based models, RNN, LSTM, self-attention model. We can adapt all these models here is also possible. Okay. Then we can go move with attention visualization technique. It is a mechanism, a model in a assign different levels of importance to different words. For army side, this one. You can go with the sports certification and then other things, we can direct it. Similarly, the machine learning is learning the pattern from the document. So from your resume, whatever history, whatever your explanation related to your certifications and training, it can judge. Okay, this is now the recruitment depends with army side, then these are all the important words. Now the recruitment based on the IT company sides, then we can give the more attention onto the CGPA other than sports certification and other things. Okay. So attention mechanism help the model decide which words deserve more focus and which words requires less attention. Let us consider, we have seen already cancer related. So whenever the teacher read the document, that history, your teacher or patient or doctor, malignant lung tumor abnormal cell, these words are very important. We need to focus on the document. The words such as the, has, with, these words are white space words. We no need to consider this one. So we need give attention more on which words, we neglect which word, partially consider which word, everything we can do with the explainable AI techniques. Okay, so and some of the difference also there. LIME is post hoc explanation, which means after prediction it will give the explanation, but shape also gives us post hoc explanation, but attention gives while the during the model analysis is going on, that time it can separate. These are all the most important words from this document. These are all the words slightly important and that is moderately important, and these are all the words we no need to consider. During the analysis is going on, the attention can do this. So these are all the differences between them. Okay, so hope you all understood by these techniques. Some other techniques also there, wherever we can apply all these techniques: machine translation, question answering, medical natural language processing related documents, patient history, and chat bots, large language models adapt with these techniques, document classification, we can use all these explainable AI techniques with machine learning and deep learning contribution also, transformer model also. Okay, so now, okay, and some of the example is there. That is not important. We have seen already previous example. Once again, just for my preparation, just I would like to explain this example also. For example, entrance score is 60, required cutoff is 70. The prediction says admission not granted. The counterfactual explanation, because here is why you are not selected. If the entrance score was 70 instead of 68, the admission decision would change. Notice the difference between the word admission not granted instead of if the entrance score were 70 instead of 68. Then if you improve 2 more from other tests, the admission decision would change. So the admission related entrance test, for example, SRM University and your college is introducing the entrance exam na. So several level also there. First time you can attend, a person can attend 3 times is possible. Then the word gives us if the entrance score were 70, you can pass the exam is possible. Then this is a positive sentence compared to admission not granted. Okay, so you can apply the second time also possible from this positive. It will make by this explainable AI is possible. Okay, therefore we are moving with explainable AI. Previously we have seen what is black box AI, why we need explainable AI, all these things we have seen already. Okay, so next for time consuming problem, just I will run the code for your understanding purpose. I run the code with the shape ordinary without the shape and line. Look at here how we do the Python programming. You can fetch the code from ChatGPT or any other online resources, but you must understand the logic behind this. Fundamental principles of shape, line, and how it differs from traditional artificial intelligence, machine learning, and deep learning algorithms. So, how do we do that? I don't want to explain each and every sentence, just what contributions and how it made. That's only is enough. So first we need to install pandas and then matplotlib for graph, pandas for numerical calculation and array oriented. The numpy is also array oriented. Pandas for data frame like Excel sheet you want to read, CSV file you want to read, PDF you want to read. Then we need these pandas and other things. So after library, we want to do the feature extraction. So we need these libraries and the machine learning algorithm. Any machine learning algorithm, appropriate algorithm, you can use it here. Instead of logistic regression, you can use support vector machine also. After that, we need to split our data set into training set and a test set. Training set means I am training some of the people for sports in your class, let us assume. Test means after training, some of the new student will come. I test already the trained people is good or not. Then only we can test with the new people, isn't it? Similarly, based on the trained model output, the test also given as the input. We test whether the model pre-trained model accuracy and output is good or not. So we need the split up set and set for our data set. Data set where we can collect UCI machine learning repository and other online resources, Kaggle, GitHub, like that. But for our purpose, I am the biopsy report and some of the cancer tissue related information, malignant breast cancer cells related information. Okay, no cancer reports also we have. From these two documents, I am labeling cancer for first sentence. For this first one related to cancer or not, saying non-cancer related to documents wherever possible. All these non-cancer possibilities I given. I label separate it. First one related to cancer document, second label non-cancer related to second document data set. So hope you all understood what is data set and how we label it using NLP related to it. After that, the data means this data set, the report, medical report data set here is there na, we need to convert it into data frame. Then only we can make it as a prediction and other things. After data frame, test set, data set training, then we introducing the label cancer and non-cancer. And after that training set and the test set, 75% of training, 25% of test, we can separate it, or 80-20, 70-30. Training purpose and the test purpose, you split the data set. After that, you are introducing the model logistic regression command. Whatever syntax we have, we need to apply it. Other than that, any other appropriate algorithm also you can use it here. And you are feed your training set for model fitness. Then it will take your training set. The logistic regression model is a predefined algorithm. It will take your input and will give the result. So classification report results we can get. Look at here. After that, in our NLP related techniques we need na. So here TD and IDF, what it is, just without shape and line, ordinary text documentation, inverse document frequency. That is a technique. We import these techniques for the prediction from the document. What we can get the output? These are all the documents from the healthcare data set. These are all the document cancer. These are all the document non-cancer. So the accuracy, 80% of accuracy we got it. And the precision, recall, F1 score. These are all what? Which means F1 score is harmonic mean between accuracy, precision and recall. Precision means what? Accuracy only, we cannot say that 80% we scored. How much patient, how many, let us assume how many patients involved here, 100 patients. Doctor says you have COVID, 20% of people, let us assume. That 20% are 80% possible. Therefore, they are asking you get a MRI scan because symptoms not clearly says you have COVID. After that, they can predict whether COVID or not. So improve the accuracy is possible. That is precision recall, how much true positive rate, false positive rate. All these things calculated. You need to understand and interpret the output. This is a machine learning model output. What it means, you need to understand and interpret all these things. Okay, so here the meaning is anyway accuracy 80% yielded. This inverse document frequency and the term this method TD-IDF works well, but it says from the label only it can say the output. But if we go with shape, introduce shape, the same program, whatever other library we need, just I import it, that's all, and import the shape technique. Okay, previously we have seen lime na. First we introduce lime technique. So install lime technique. This command only enough. These are all installed. After that, the same concept we are using. That is the same data set. Some more sentences we can add. This is for sample only. Large amount, gigabyte level, you can use the PDF also possible. For your understanding purpose, I am taking this small document. Okay, cancer related, non-cancer related. After that labeling, after the labeling, I am doing this model, implement the same logistic regression machine learning model. Then training set, test set we are using here. Now clinical report, the biopsy confirmed malignant tumor with metastatic cancer cells. This report also the prediction we have. The medical reports, cancer, non-cancer related information. It use the clinical report also. And after that, the line introduced here, the line text explainer. Okay, so how do we implement the line? This is the model. Later I will send it to you. You just copy and paste it in your Google Colab. Train these algorithms, then you can implement with anywhere is possible. The lime explanation. From the output, you can understand the previous output without lime. TD, text documentation, inverse documents frequency method only provide this output. Na? Look at the NLP lime technique output. Malignant contribute how much? biopsy word contribute how much in the sentence or report, clinical report. So these are all the important word contribute how much percentage in the document. Therefore, the machine learning model says, I am predicting cancer for this patient, non-cancer for this patient because of in the clinical report says these important words this much level. Okay. So this is the explanation. The explanation can be drafted into graph also possible. So why is malignant ranked first? Because during the training model learned about malignant appeared mostly in the cancer reports. Okay. So be careful about report, clinical report first. If we feed the proper clinical report, the AI can predict well. The XAI can predict well. Then after that, we have seen all these report word importance from line. Then shape. What is the shape report? After implementing shape model, similarly, I'm using the same data set, same labeling, cancer, non-cancer labeling. Okay, all the techniques are same. Similarly, the clinical report is also there. Then now look at the after implementing shape explainer in this model, what we can get as a output. Here we have the shape values with absolute accuracy. Shape value means we have seen what is shape value. How much contribution in the cricket team, batter, bowler, everyone contribute how much. That percentage of contribution, feature contribution is shapely value or shape value. That can be achieved by shape technique. Now we can understand how much accuracy we yielded, what's the reason behind this one, what are all the words contributed for this clinical report, how much contribute in every word. So from this, the NLP techniques, XAI giving this report. Now we are using the same machine learning model, traditional machine learning model, logistic regression in everywhere, TD, IDF program, as well as NLP, LIME, and then shape. But that prediction, logistic regression prediction accuracy, how we yielded from these feature contribution. LIME gives us the percentage of contribution only. Shape give more attention for that every feature contribution, how much contributed to lead this disease. Similarly, you can use it with network security, intruder related information, and on the other financial domain or any law documentation side, you can fetch the proper important word, how much contributed, why the prediction made by this machine learning or deep learning algorithm. You can explain, like a doctor, how he explain to the patient, because of these reasons you lead this disease, you follow up these things like that. Similarly, here NLP techniques, not only NLP techniques, the shape and LIME feature contribution level, if we want to get it in any domain, then we can use this explainable AI is possible. Okay, hope you all understood by this technique. Thank you all. If any questions, please let me know.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am, for the informative and engaging session. We will now begin the live question and answering session.
Okay, yes, please. How do we apply the clustering processing in NLP? Which is very simple. Already we have the machine learning algorithm for clustering, KNN, K nearest neighbor, and other several clustering techniques are there now. So you can implement all the clustering technique, adapt with this explainable AI. This explainable AI techniques like shape, LIME, and other techniques tells us feature importance, why you are KNN, how it will work, neighboring cells similarity, that is classification. We have the labeled Excel sheet like that. Clustering means we don't have the label. For example, we are collecting the information from population, which means the Excel sheet contain diabetes patient means glucose level, Glucose is one of the feature in the Excel sheet column contain, HbA1c column contain, and all other features, obesity, heredity, BMI, everything is as a column name with values are available in the Excel sheet. This is called supervised learning algorithm. Learning as well as values, that is labels as well as values we have in this data set. On the other hand, we don't have the label means I am asking you 10 peoples, please collect in the surrounding nearby Thanjavur or any street. You collect the BMI of the people. Some of the information, diabetes related information, you go and collect home by individually. So the group going and collecting information, they are writing in their documentation. They don't have the label. Later we need to find out the category from the collected value. Then similarity of these things, these are all age groups. The number collecting 68, 70, 48, 30, these are all the number only. But after that we need to label it. Okay, this similarity can give, these are all the values of the patient or member of the home. Similarly, these are all the heredity related report. These are all the biopsy related or blood test related, glucose related, HbA1c related. We are doing this similarity level using, for example, K nearest neighbor algorithm. Several other clustering algorithm are also frequent mining, something else you can adapt. So after that, it will give the prediction result, but we need the explanation. How, which features contribute for COVID for these people, diabetes for these people. It can be done through explainable AI, shape, lime, and other techniques. That's all. Is it clear? And now you are asking how to convert audio file to text file and text file to audio file. So there are several techniques available to convert these files. You want to convert speech to text, text to speech. This is how we using machine learning algorithm. Similarly, some other techniques are also available in the machine learning algorithm. You need to fetch it and appropriate information. It depends your domain. And after implementing these techniques, we can apply explainable AI. Okay, so this is not a webinar, which techniques are useful for all these things. So several techniques are there. Okay, so that techniques helpful to convert it. Some, for example, the traditional techniques are wavelet transform technique. Why I'm saying this traditional techniques means in your physical lab, wavelet transform, how it will work, working principles you can understand. Some other techniques like Fourier transform. These are all physics dependent oriented. Fourier transform, wavelet transform. These are all the techniques which can import these techniques to our deep learning model and convert these speech to text like other methods are possible. In depth, we can adapt. These are all only old technique. Why I am saying the old technique means because you studied already in your physics UG or school level. Nowadays, several techniques introduced. You can adapt and you can implement along with the deep learning algorithm, ensemble model, hybrid model, all are possible. After that, you can apply explainable AI. How after speech to text and text to speech, anything, the output percentage, why you get that explanation can be asked or can be done through this shape and lime explainable AI is possible. Okay. Is it clear? Thank you. Is any other question? Anyway, 1:30 is our time. I am taking so long time. Thank you for your patience. Do you have any other question? Please let me know. Shall I wind up this meeting? Yes. Yes, ma'am.
Now I call upon Miss Bhavadani to deliver the vote of thanks. Okay, ma'am. Thank you, ma'am.
Thank you.
Our esteemed Secretary, Mrs. Punita Ganesan Madam, our visionary strategic Professor G. Vikram Surya Prasad Sir, our distinguished Director Academic K. Samim Rani Ma'am, our Honorable Principal K. Dr. Kumar Sir, our esteemed IQC Director Professor M. Suguma Sir, our eminent resource person Dr. Palanisamy Naveen Madam and Dr. Usha Rani Madam, distinguished principal, head of the department, faculty members, researchers, industrial experts, dear participant, students. A very pleasant afternoon to everyone. It's my proud privilege to express the vote of thanks on behalf of the Department of Computer Science and the Department of Artificial Intelligence and Machine Learning, Bharath College of Science and Management, Autonomous Thanjavur. At the successful conclusion of the one-day international web conference on the advance in explainable and religion AI for the security and language intelligence. First and foremost, I express our sincere gratitude to our Secretary Madam Mrs. Punita Ganesan for visionary leadership, unwavering encouragement, and continued support, academic excellence, and research innovative. I also extend my sincere thanks to all the participants head of the department, faculty members, researchers, industrial experts, and participants for your various institutions across India and abroad for the participants' insightful interaction and variable contribution that made today's conference intelligent, enriched. My heartfelt thanks to our organizing committee, IQSC, faculty, technical support team, student volunteers, and every individual who worked tireless behind the section. Your dedication, teamwork, and planning ensure the seamless execution of this conference. Thank you all.
Remana, ni budiya.
உள்ள போய் யாரு
Thank you to our distinguished speakers, faculty members, and all participants for making this webinar a success. We hope you found today's session informative and inspiring. Have a wonderful day. Thank you all. Please leave the session. Thank you all.